Hey everyone, in this video what we're going to do is we're going to illustrate a general method for solving reciprocal equations of even degree. But what is a reciprocal equation? Well, notice that on the left hand side of our equation we have a polynomial. It is in fact a reciprocal polynomial because if we read the coefficients in reverse order and keep the same variable powers, we get the original polynomial. Also note that the degree of our polynomial is 4 and thus our polynomial is of even degree. So what does that mean? It means that we have a reciprocal polynomial of even degree, and there is a general method for solving polynomials of this form. Now let's apply this method to our reciprocal equation above. Let's begin by multiplying each term in our expression by 1 over x squared. If we do that and we simplify our expression, we have 4x squared plus 3x plus 1 plus 3 divided by x plus 4 divided by x squared is equal to 0. And let's rearrange our equation in the following way. 4x squared plus 4 divided by x squared plus 3x plus 3 divided by x plus 1 is equal to 0. Now what we're going to do is we're going to factor the constants out, and notice that we can rewrite 1 divided by x as x raised to minus 1, and this enables us to rewrite our expression as 4 multiplied by x squared plus x raised to minus 2 plus 3 multiplied by x plus x raised to minus 1 plus 1 equals 0. Now let's make the following substitution. T is equal to x plus x raised to minus 1, but notice we have x squared plus x raised to minus 2. How can we get this from our substitution? Well, let's begin by squaring both sides of our substitution. So we have t squared is equal to x plus x raised to minus 1 all squared equals x plus 1 over x multiplied by x plus 1 over x. This simplifies to x squared plus 2 plus 1 over x squared, which equals x squared plus x raised to minus 2 plus 2. And if we subtract 2 from both sides, we get t squared minus 2 is equal to x squared plus x raised to minus 2. Now let's rewrite our expression in terms of t. Doing so, we get 4 multiplied by t squared minus 2 plus 3t plus 1 equals 0. If we multiply this out, we get 4t squared minus 8 plus 3t plus 1, and this simplifies to 4t squared plus 3t minus 7 equals 0. Notice we have a quadratic equation, and to get the values of t which we want, all we need to do is solve this quadratic equation. We can do so in the following way. Notice that we can rewrite 3t as minus 4 plus 7t, so that we have 4t squared minus 4t plus 7t minus 7. If we factor out a 4t from the first two terms and a 7 from the third and fourth terms, we get 4t multiplied by t minus 1 plus 7 multiplied by t minus 1. And now if we factor out t minus 1 from both of these terms, we get t minus 1 multiplied by 4t plus 7 equals 0. And if we set both of these factors equal to 0, we get that t is equal to 1 and minus 7 divided by 4. But how can we use this information to solve our original equation? Well, let's focus on the substitution that we made. We have t is equal to x plus 1 over x. Let's multiply both sides by x. Doing so, we get tx is equal to x squared plus 1. And if we subtract tx from both sides of our equation, we get x squared minus tx plus 1 equals 0. And all we need to do is substitute in our values of t, and that'll give us the solutions to our reciprocal equation above. Also notice that the polynomial in our reciprocal equation is a quartic with real coefficients, and every quartic with real coefficients is expressible as the product of two quadratic polynomials with real coefficients. And of course we have two values of t, and we have the form of our quadratic equation. So this tells us that we can rewrite our quartic is x squared minus x plus 1 multiplied by x squared plus 7 divided by 4x plus 1. And so we can solve these two quadratic equations using the quadratic formula. In doing so, we get the following four solutions. Let's just do another example to make sure we really understand the procedure that we've just described. Given the following polynomial equation, based on what we've just learned, what can we say about it? Well, we can say that it's a reciprocal polynomial of even degree, so we know that we can apply our technique to it to solve it. Let's begin by multiplying everything by 1 divided by x squared. This gives us x squared plus 1 divided by x squared plus 2 multiplied by x plus 1 over x plus 2 equals 0. We can rewrite this as x squared plus x raised to minus 2 plus 2 multiplied by x plus x raised to minus 1 plus 2 is equal to 0. And using the substitution t is equal to x plus x raised to minus 1, we get t squared plus 2t is equal to 0. And this has the following two solutions, minus 2 and 0. Now, using the quadratic equation before, we have x squared minus tx plus 1 is equal to 0. Substituting in our values for t, we get the two following quadratic equations, x squared plus 2t plus 1 multiplied by x squared plus 1 is equal to 0, which give the following solutions. Now, you might be starting to notice a pattern here. If you have a reciprocal polynomial of even degree x raised to 2n, divide it by x raised to n. This results in n quadratic equations, which you can ultimately solve and get the solutions to your original reciprocal equation. And I feel like this is a really useful method if you're able to identify that you have a reciprocal polynomial of even degree. Anyway, that's all for this video. Let me know what you thought about it in the comment section below. Thank you very much for watching. If you have any questions or problems you'd like to see get solved in future videos, let me know in the comment section below as well. I hope you have a great day.